Hello, class. This is Mr. Eggleston, and this is the Algebra 1 Spring Midterm Review. It's basically covering units 4 through 6, more specifically 4 through about 6.3, because we're not going to get all the way through 6 by the time I give this to you. All right, so this is from Unit 4, Solving Systems. You have like 3 of these. And then the next stuff will be from Unit 5, and then at the end will be Unit 6 stuff. So it's pretty much in order, at least this review is. This is solving a system of equations. They want you to solve for A and B. So the easiest way to do this would be to, you can see that, hey, that we can get A from just dividing 49 by 7. And you get 7. So we have A. I would plug it back in to the top equation and then solve for B. So 6 times 7, 7 is 42 equals 54. Negative 3B equals 54 minus 42, which I believe is 12. And you get B equals 12 over negative 3 or negative 4. We got B. We can now plug it in. Or no, we got B. We got A. We got the solution. I'm writing my ordered pair as AB because A comes for B in the alphabet. So that's 7 comma negative 4. And that would be the solution. All right, the second one is a word problem, which we all love. East Kentwood High School sold 71 student tickets. So I'm going to let X equal price of stud ticket. And Y equals price of adult tick. Okay. And so they sold 71 student tickets. That would be 71X. And 92, lots of tickets, 92Y for adult tickets. And remember, X and Y are the price of students' tickets and adult tickets, respectively. And they made $1,509, $1,509. The next one was 56 student tickets. And again, this is what makes this one relatively easy, 92 adult tickets. And they made $1,404. Well, notice the adult ticket number sold were the same for both nights. So I would kill the adult tickets, which is unfortunate because we want to know the cost of the adult tickets. We want to solve for Y, but we're going to kill Y. We'll solve for X and then have to substitute it back in. So to kill Y, I'm going to multiply the bottom equation by basically negative 1. Okay, which gives me negative 56X minus 92Y equals a negative 1,404. Now, I don't care about this because I just modified it, and I'm going to combine these two. Okay? So 71 minus 56, I'll do this in my head, so to speak, which is really just, I'm too tired to want to try to pretend I can do it in my head. You get 15X. And then 1,509 minus 1,404 is 105. So X is going to be 105 divided by 15, which I hope is a nice integer, which it is. And that works out to be 7. That means the cost of a student ticket is $7, but we don't really want the student ticket cost. We want to solve for Y, the adult ticket price. So we can substitute x equals 7 into the top equation. That was 71. Now it's x, but x was 7. And now plus 92y. And that's got to equal 1509. I'm looking at this equation. Okay. Modifying it, 71 times 7 is 497 plus 92y equals 150. Subtract equals 1509. 1509. I was like, wait, that's coming out negative. So we're going to subtract 497 from 1509. And we get 1012. So over here, we got 92y equals 1012. Divide by 92. And we got 11. So adult tickets, I'll write right here. No, that's way too fat now. Adult tickets yes, I know I misspelled the T. Cost $11. And that's the answer. You could also say the student tickets cost 7. All right. Determine if the system has 0, 1, or infinitely many solutions. Give a reason for your answer. Quickest way. They don't want you to solve this. You don't have to. You could try. You'll probably find out that the solution is kind of ugly if there is one. The other option is they just want to know how many solutions. And you know if the slopes are the same between these two lines, then that means they're either parallel lines or the same line. Parallel lines mean no solution, same line means many solutions, or if the slopes are not the same, then those two lines have to cross. So I would probably just look for the slopes of each of these. So the top line is the opposite of B over A. It's opposite of A over B. Opposite of, it's opposite. I don't know. I'm dyslexic. Sorry. It's the opposite of A over B. A being -5, so the opposite's 5. B meaning 4, so it's 5/4. The slope of the bottom line is going to be the opposite, again, A over B, and I'm referencing the standard form of the equation, AX plus BY equals C. The A and the B are the numbers in front of X and Y. So in this case, it's going to be -20 over -12, which is positive. 4 goes into both, and that's 5/3. The slopes are not the same. So there's one solution. If the slopes were, we would then have to check the y-intercepts, or to see if they have the same y-intercept and same slope, then many solutions. And if they have the same different y-intercepts but the same slope, that would be no solutions. Slopes are not the same, one solution. Okay. Question 4, a table of selected values for a function, f, is given. Find f evaluate at -2. Notice, they don't give us the value. Oh, yes, they do. I'm sorry. This is easy. We notice that in the table, -2, which is the input, the x, they give you a value of 6. So you just read the table, and this equals 6. Which is greater, f of 0 or f of 0 or f of 8? So is 3 or negative 2? Which one's greater? F of 0, because 3 is bigger than negative 2. All right, number 5. The function a of s equals 6s squared. They tell you it represents the surface area in square inches. It's important to know that. Of a cube with a side length of s inches. And they want you just to evaluate. What is a evaluated at 8.5? A of 8.5, you just plug in 8.5 in for s. That's just going to be 6 times 8.5 squared. You need a calculator. So it's 6 times 8.5 squared. And that's going to be 433.5. Okay. Interpret your answer in part A in the context of the problem. Well, yes, it's 433.5. So that means a a cube of side length 8.5 inches has a surface area, SA, equal to 433.5 square inches, because it's inches squared, because you squared it. So use function notation to express that a cube with side length of 7 has 294 square inches. Well, that's just going to be a of 7 equals 294. All right. Determine if each relation can be represented as a function. Okay, so the first one's a graph, and I hope you recognize it can't be because it doesn't pass the vertical line test. So no. Okay. They don't ask you to say why. You could say because it doesn't pass the vertical line test. Remember, vertical line test says if you drop a vertical line and if it touches the graph anywhere more than once at any given location of x, it's not a function. If it touches only once, then it is a function, so not a function. Okay. B, we look at the ordered pairs, the inputs. 1, 2, 1 right here. 1 goes to 5 and 1 goes to 3. That is definitely not a function because 1 should only go to one number. So you should, basically when they give you a table, it's real easy. You just look at the table and see if any of the inputs, any of the x's repeat. So this is not a function. Now this is a function. How do we know? Because you know what the shape of that graph is. In your mind, you don't have to draw this, but this is what's going on. You don't even have to be precise, i.e. with the y-intercept being -3 and the slope of 1. You just know that if you were to graph this line will look like that. And you see, this actually does pass the vertical line test. So it is a function. All right, question 7. This is the last one before I stop the video and start a new video. All right? Because there's 14 of these. A table of selected values and a graph for a function y equals h of x are given. So this is h of x. Okay? So they give you h of x both in a table and in a graph. They say evaluate h at -2. Problem with h at -2, I look at the table, and it doesn't show up. -2 is none of the inputs. So that means I look at the graph, and negative 2 is right there. So the graph tells us it's going to be equal to 0 because it's the x-intercept. H of 4, I notice that 4 does show up on the table, so I'm just going to write down that it equals 9. H at negative 3 also shows up. It's going to be negative 12. Notice, I just went right to the table to check to see if those numbers show up. If not, I'm going to have to read the graph. Explain how you can use both the table and the graph to find the y-intercept of h. Y-int is x equals 0. On table, just read the number. On graph, see where it crosses the y-axis. When is t helpful? When is it helpful to use the table to evaluate a function? When the input, which is x, is on the table. You just read the table. You don't have to think. On the table. Okay? When is it helpful to use a graph to evaluate a function? When the value, the x value, is not on the table. Then you have to use the graph to read it off. All right, and that's it on the Part A video. Okay?